Yes, let's complete. I set you to name here. I'll count how many carbon, and then here we have just one carbon, so it will be meth. And for hydrogen, so methane, methane, like this, A-N-E. And here, one, two, three, so it will be prop. Prop what? Propane, because there is no evidence that I have double bond. I have only single bonding between carbon and carbon. And here, one, two, three, four, five. So it is pentane. But here I have double bonding, so I'll use the suffix "-ene". How many carbon in the beginning? One, two, three. So it will be propene. I forgot to say to you something. In case of alkene, the smallest compound formula is ethene, 2 carbon. There is no methane. We have methane, but there is no methane because meth means just 1 carbon and there is no double bond here in case of so there is no methane. We have ethene is the least thing, and here we have double bond, so I'll use the suffix "-ene". How many carbon? 2, so it will be eth. What is the name? Ethene. And here 1, 2, 3, 4 carbons, so it butane or ene, because we have double bond. Where is the position of the double bond with carbon number 1? From where, your teacher, you know that's number 1, because I'll start to count from the long chain. Here we have 1 carbon, but here we have 1, 2, 3. So I'll start my counting from the short side. 1, 2, 3, 4. So 4, it will be but 1 in. This explained to me that is the double bonding with carbon number 1. And how I can draw displayed formula. Butane, So I draw 1, 2, 3, 4 carbon, and between them single bond because we have ane. And ethane, so I draw 2 carbon and between them single bond and complete with hydrogen. Also here complete with hydrogen. Let's draw this but-2-ene. That's okay. I'll write it here. But-2-ene. From where I start my drawing? From the word but. So but means 4 carbon. 1, 2, 3, 4. And I have the suffix "-ene, so I have double bond. Where is the position of double bond with carbon number 2? Where I put number 2, it's up to you. You will draw. So you can start from here, number 1, or you can start from here, number 1. Let's start this time from here. This is 1, 2, 3, and 4. Because I draw. But when I name, I have to count from the short chain. Carbon number 2, this is carbon number 1. This is carbon number 2, double bonding. Okay, and complete. Hydrogen, hydrogen, hydrogen. How many hydrogen here? 1, 2, 3, 4. So I can't put here. Here, 1 hydrogen, 2, 3, and this is the fourth bonding. Here, 2 bonding, 3, 4, only 1 H. And here, 1, 2, 3, 4. This is the full displayed formula. Okay, sorry. How I can change it into a structural formula is C, first C with 3H and CH. Here, let me put H up and down because I have to put carbon beside carbon to make double bonding, and H, and here CH3, like this. Okay, let's complete. Here, propane. So, prop, how many carbon? Sorry. Prop, so 3 carbon. Single bond, so I'll draw 3 carbon between them single bond and complete with hydrogen. Look here, methanol. I made a circle around the suffix ol. Suffix ol means that I talk about alcohol. So any ol means alcohol, and any ol means that I have to add OH like this. I want to draw methanol. Methanol. Okay, the suffix ol means that I have an alcohol and with OH like this. Okay, meth, so we have one carbon with 4 arms. One of them will carry OH. Where, your teacher, I'll put OH? Put it in any place you want. OH here or up or down, there, like this. And complete with H. So we have meth, just one carbon, and also methanol. So any alcohol contain OH. Take care. May I ask you I give you a group of formulas and ask you to get the alcohol. So you will search about the OH. When you find OH, so this is your alcohol. Okay? The last thing in our chapter, what we call isomerism. What does it mean by isomerism? It is a special property, structural isomerism. Structural isomerism in page 153. Okay, what does it mean by structural isomerism? Structural isomerism means that I have molecules with the same molecular formula but different in structural formula. This is the definition, and you will find this definition also in your guidebook, page 61, in this table. So, what does it mean by structural isomerism? You can find more than one molecule with the same molecular formula but different in displayed formula. Let's try here C4H10. Attention, C4H10. So I talk about what? Girls, now you know. C4H10. Is it alkane or alkene? Let's see. A number of carbon 4 and number of hydrogen 2 multiply 4 equal 8 plus 2. So it's alkane with single bond. You understand from where I knew it? From the general formula. Okay, so here I have C, 4C, 1, 2, 3, 4. What is the bond between them? Single bonding, okay? And complete with hydrogen. Attention, please. Like this. This is C4H10. What is the name? C4. So butane. Because when I count the number of hydrogen, I found it 2 multiply 4 plus 2. So it's a single bonding. Okay? Let's change this into structural formula. Yalla, with me. CH3, CH2, CH2, CH3. I'll write it back. Again, CH3, CH2, CH2, CH3. C4H10. So the structural formula CH3, CH2, CH2, CH3. Okay. Take care. I'll talk about structural isomerism. What does it mean by structural isomerism? I have the same molecular formula but different is displayed formula. That's to say, I have many molecules with this number of carbon and hydrogen, but different in the displayed formula, different in the structural formula. Let's see how. Okay, I'll keep the CH3 as it is. Okay, and these two, I'll take one of them to here. So I have just one H, so it will be CH. And here, this two, I'll take one, it will become CH3. So here, I'll put CH3, hang it down. Again, you understand what happened? I have CH3, I write it as it is. I'll take one hydrogen from here, make it or add it to the next hydrogen here. So now I have CH3, which is methyl group. I hang it down with what? With the CH, because I took one here. So I have CH3. What's left? CH3. Let's name this compound. I'll count from the long chain. 1, 2, 3. So it will be prop. Prop. An or in? An. And in the beginning, I have to hang methyl group in which carbon? In carbon number 2. So we have 2 methyl propane. Let me write it again. You see here, it's butane. But 4. This is the structural formula. This C4H10 can give me another organic compound with the same molecular formula but different in the displayed formula. How? This is the CH4. I'll take one hydrogen from here, so what's left? Just CH. This is the CH. And this one hydrogen added to here, so I have CH3. So this CH3 will hang with the carbon as methyl group. And what's left here? CH3. Don't say that's methyl. No. Because this is the long chain. Methyl hanged side, not with long chain. I want to name this compound. I'll start to count how many carbon in the long chain. 1, 2, 3. 3. So it will be prop. Single bond, so it will be an. But I have methyl group. This is methyl. Hang it in which carbon? 1, 2, 3. If I count from left, it will be 1, 2, 3. If I count from right, it will be 1, 2, 3. So carbon number 2. So this is 2 methyl propane. طيب كم كربون؟ 1 2 3 4. ادي 4 كربون. كم هيدروجين؟ 3 plus 3 plus 3 plus 1 equal 10. So I have the same molecular formula C4H10, but here butane and here 2 methyl propane. So butane and 2 methyl propane are structural isomerism. Structural isomerism, that's to say I have molecules with the same number of or with the same molecular formula, same number of carbon and hydrogen, okay, but different in the structural formula, like this. This is the structural isomerism. Thank you and best wishes. Your homework is to answer question number 1, page 155. Number one, letter A and letter B. Please try to do them yourself, okay? And then I'll check with you next period, inshallah. I solve it with you orally, but I want from you to write the name and to draw a displayed formula, to memorize well what does it mean by structural isomerism, what does it mean by alkane, what does it mean by alkene, alkane with single carbon-carbon bonding and alkene with double carbon-carbon bonding. When I put the number before the name, when I have branched chain like methyl or ethyl, okay? Till now we use methyl only. And where I can put the number in the middle to explain the position of the double bonding in case of alkene. Thank you and best wishes.